Hi, my name is Diana, and this is my video lab report for Physics 2212 with Dr. Barron's Lab 2 Lines of Charge. The purpose of this experiment was to create a computational model of two charged tapes exerting an electric force on each other while experiencing gravitational force, and estimating the net charge on each tape by modeling the tape as a line charge. The results of the experiment are that when modeling the tape as a line charge, Q equals 2.39 times 10 to the negative 8 coulombs, as opposed to in Lab 1 when the tape was modeled as a point charge, Q equaled 1.07 times 10 to the negative 8 coulombs. So, modeling the tape as a line charge results in a larger Q. Some important background concepts are Coulomb's law, which explains why like charges repel and opposite charges attract, and the formula is shown in the slide. The force of gravity, which is given by the equation shown, Newton's second law, where the two forces acting in this experiment are electric and gravitational force, and an electric force equation where the force equals Q, or charge, times the electric field. The models for this lab are an experimental model and a computational model where the system is the tape floating and the surrounding is the bottom tape in the earth. Some assumptions are that each U-tape has the same net charge, each U-tape is treated like a line charge with an equal distribution of charge, and air resistance is negligible. The reasoning for these assumptions is to get a better approximation of the tape's charge than Lab 1, where I treated each U-tape as a point charge. Here's a quick summary of Lab 1. The experiment procedures for Lab 1 are shown to the left, and the initial conditions are shown in the table to the right. Here are the calculations from the experiment in Lab 1. I calculated force of gravity, force of electricity, and the charge of the U-tape, the number of excess and deficient electrons, and the ratio of electrons to atoms. For Lab 1, I treated the tape as a point charge to simplify calculations, and I used the initial conditions I gathered from the experiment. Here's the code for Lab 1, and the Q, the charge on the tape was 1.07 times 10 to the negative 8 coulombs, which matches my experiment calculations. Here's where I talk about Lab 2 and my computational model where I treated the tapes as line charges. Just to recap on assumptions, we are assuming that each U-tape has the same net charge, each U-tape is treated like a line charge with equal distribution of charge, the air resistance and interactions of forces within the same strip of tape are negligible. We also approximated the mass of the tape by 1 gram for 1 meter of tape. Walking through the code for Lab 2 computational model, first we define the constants and put in the Lab 1 data. On line 13, I used trial and error to determine the new Q to make Fe equal to Fg, and next we define the electric field function. After that, we define the line of charges function, then we create the top and bottom tape objects. Next, we use nested for loops to model superposition and create electric field arrows. Finally, we create different colored arrows to represent force of electricity and force of gravity, and then display calculation results. Here is the Lab 2 model results. The yellow arrow is the electric force, the green arrow is the gravitational force. The orange arrows are the electric field, the red balls are the top tape or the U-tape, which is the system, and the blue balls are the bottom tape, which is the surrounding. From this computational model, I estimated the Q to be around 2.4 times 10 to the negative 8 coulombs, which is determined by testing what value of Q would make the electric force equivalent to the gravitational force. This is a 76% difference from the value of Q approximated in Lab 1, which is 1.07 times 10 to the negative 8 coulombs, and the Lab 1 value was computed by assuming the tape was a point charge. Some sources of error through this lab could be loss of charge when handling the tape, estimating weight and other measurement/rounding error, error from using trial and error to determine the Lab 2 Q value, and only using 50 point charges to approximate the Lab 2 Q value, as more point charges result in a better approximation. There's also errors from assumptions, such as treating the tape as a point charge for Lab 1, which is why the Lab 2 result for Q differs greatly, assuming each tape has the same charge and ignoring air resistance. What if? From Lab 1, where we modeled the tapes as a single point charge, we got a Q value of 1.07 times 10 to the negative 8 coulombs, whereas from Lab 2, where we used a line charge model, we got a Q value of 2.39 times 10 to the negative 8 coulombs. Compare the two values, so we see the line charge Q is around double the value of the point charge Q, and there's a percent difference around 76%. But why? Which value is likely to be more precise and closer to the real value? Well, the estimates differ because they use different levels of precision, and the line charge model is more likely to be closer to the real value because it uses smaller step sizes and therefore a better approximation. Furthermore, it better models the real electric field of a strip of tape.